All right, so this is the last video of notes 3, and we're going to be doing some simplifying of radicals. Now, that does not mean you put it in a calculator and you get me some decimal value. This means we're going to simplify and look for perfect squares, or in the case of cube roots, things like that. So, how do we do it? Couple of options. Option 1. If you know, in the case of problem number 4 here, all the parts that we're dealing with are all square roots. So if you know your perfect squares, then you can just look for a perfect square that is a factor of your the number under the radical. Now, you might be asking, well, what's a perfect square? So I'm going to make a list off to the side here. All right, so perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100 are the first 10 perfect squares. These are not random numbers. It's not just the first 10 numbers I could think of. It's each one of these numbers is what happens when you take a number and you square it. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, leading down to 10 squared. Okay, so if you know those, one way to simplify a square, the square root of 8, you'll notice 8 is not on this list, but the number 4 is. And so I can rewrite the square root of 8 as 4 times 2. We all know 4 times 2 makes 8. Now, why did I pick 4 and 2? I picked 4 because it's on my perfect square list. So the square root of 4 is 2. And then this 2, I'm going to underline it here in blue, that 2 is not on my perfect square list, so it stays under the radical. And so the square root of 8 in its most simple form, not a decimal, is 2 root 2. So I'm going to do the same thing with part B here, which is root 27. 27, not on my list, but I'm going to pick a number on my list that divides into 27. That is a factor of 27, and that is 9. So the rewrite step, square root of 9 times 3, right? Square root of 3. So we know 9 times 3 is 27. Well, the square root of 9 is 3. And then root 3 stays, well, root 3. I can't do anything with that one. So square root of 27 is 3 root 3. All right, so that's one way to do it. Let's say you don't know your perfect squares, or you're looking at like a number like 48 and thinking there's so many things that go in there. So one of the things that we've done with GCF, LCM is we've looked at these factor trees. Let's do a factor tree on 48. So anything that multiplies to 48, how about 6 times 8? Neither one of these are prime numbers, so I can keep going. So 2 times 3 makes 6. So 2, 3 for 8, I can do 2 and 4. And then 4 is 2 and 2. And I'm just going to rewrite this all. So how many total 2's do I have? I've got 1, 2, 3, 4 2's. So 2, 2, 2, and 2, and then 1, 3 here. Okay. And so this is all still underneath a square root. Okay. And what we're looking for is when we're dealing with a square root, we're looking for pairs of numbers that match. So I've got a pair of 2's, and I have another pair of 2's. That means that for each one of those pairs, I can take a single 2 outside of the radical. So it's just this pair of 2's underneath the square root becomes a single 2 outside the root. This pair of 2's is also going to become a single 2 outside of the root. Notice I put the little multiplication dot. I'm going to have to multiply. And the single solitary little 3 here that's left over, that stays under the root. So the pairs come out as singletons. Anything that can't pair up stays underneath. So underneath the root. So this is going to become 4. 2 times 2 is 4. Root 3. And that is the simplified version of root 48. All right. Let's say I do the same kind of thing for a 50. All right. I'm going to look to do a factor tree. And let's say I use 5 times 10. Well, 5 is a prime number. 10 would be 2 and 5. So 2's prime number, 5's a prime number. So let's see. Underneath the root here, I could do a rewrite. I have a single 2 and then 5 and 5. So there's my single 2. There's one of the 5s. There's everything matches up. So what am I looking for? I'm looking for pairs. Well, 2 doesn't pair up with anything, but I have a pair of 5s. So that means a single 5 comes out front and root 2 stays root 2. And so that means that root 50 can simplify to 5 root 2. Now, E and F look a little different because in this case, both of them have a coefficient sitting in front. But here's the thing. Temporarily ignore that. Just focus on the root. So how do we simplify a root 18? Well, if you know your perfect squares, I'm going to do one of these as a perfect square, one of these as a factor tree. So let's say I do 18 as a perfect square. So we're going to ignore the 2 for right now. It's there. And then 18, looking at my list of perfect squares, I know that's 9 times 2. Okay. So this 2 right here is just going to stay a 2. So there's my 2. The square root of 9 is 3. All of this is multiplication, so a multiplication dot there. And then this 2 is not a perfect square. I can't do anything with it. So we're just going to leave it root 2. So then I can multiply what I can here. 2 times 3 makes 6, root 2. That is the simplified version of 2 root 18. Now, if you don't know your perfect squares, totally fine. Let's go ahead and do a factor tree on 75. And no, I don't want to touch the minus 3 in front, so I'm just going to leave it. So as far as our factor tree goes, I've got, let's see, 3 times 25. So 3 is going to stay there. Let's do 5 and 5 for 25. All right, cool. So the negative 3 stays negative 3. And then underneath the root, I have a single 3, a 5, and a 5. Little multiplication dots to separate everything. Looking for a pair here. I don't have a pair of 3s because no, I can't go this 3 and this 3 pair up. That's not how it works. It has to be a pair underneath the root. So if I look at this pair, I do have a pair of 5s. So let's put it all together here. We've got the negative 3 that we started with. The pair of 5s comes out as a single. And then I've got a root 3 here. So negative 3 times 5 is negative 15. Root 3 stays root 3. All right, so a couple different methods to simplify radicals without turning them into decimals. These are simplified exact answers. Please let me know if you have any questions or concerns.